All right, sorry for the break. And then this last little question gives us a galvanic cell. And it says that the galvanic cell is made of copper and cadmium. And it says that its standard cell potential is 0.74, but in this modified setup, I've basically adjusted the concentration of the cadmium solution in the anode compartment. And the cell voltage that I measured was 0.71. So somehow I manipulated this to produce less of a voltage than the standard voltage is. And that makes sense based on what we know about concentrations. What I'm asked is basically what concentration of cadmium must exist in that anode department for me to have recorded this voltage. So it tells me to use the Nernst equation, but even if it didn't, I would know that the Nernst equation is what I want to use, which is that bottom equation on your formula sheet. E cell equals E naught cell minus RT over NF ln Q. Okay, so let's just start substituting in values here. My E cell, my measured value, is 0.61 volts. My E naught cell, my standard value, is 0.74 volts. Minus, let's do a big set of parentheses there, RT, 8.314 times 298. I wasn't given a temperature here, so I'll just assume that it's standard temperature. And I wrote the question, so I know that it's standard temperature. Times over NF. So N is my number of electrons or moles of electrons that are moving, which is 2. Times F, which is Faraday's constant, 96,485. Ln of Q. And what is Q in this case? Well, Q is my concentration of cadmium over my concentration of copper, because I only have copper and cadmium in solution, so they're the only thing that's in there. And so my concentration of cadmium, since that's what I'm looking for, is just over 1 molar, because I know my concentration of copper is the same, because that's what it says right there. So ln of basically concentration of cadmium over 1. So let's do some quick algebra here. If I go through, I basically solve through my algebra on, if I combine like all these terms, then I'm going to end up with 10.1 equals the natural log of my cadmium concentration over 1, which means E raised to the 10.1, or 24,966, equals my concentration of cadmium over 1. So that's my answer, 24,966 molar. Wow, that is unrealistically high. This is a poorly written question. Whoever wrote this, me. This is unrealistic. You would never actually get a molarity this high. And the reason that it is this high is because concentration cells don't actually manipulate the voltage that much. But I wanted us to get kind of a look at what would happen. Normally, what's much more likely to happen is you lower the concentration by, 0.2 molar, and you get a voltage difference that's like, very, very barely different. But anyways, in this problem, it was significantly different. So apparently we had 24,000 moles of cadmium on hand to 25,000 moles of cadmium. The next question, for the reaction above, calculate the amount of moles of cadmium salt used to produce 500 milliliters of the concentration. Okay, so basically, how much cadmium did I use? So I made 500 milliliters of this solution. For every 1,000 milliliters, there's 1 liter, and for every 1 liter of solution, there were 24,966 moles of cadmium in that solution. So how many moles of cadmium were in my 500 milliliter? 12,483 moles of cadmium were in that 500 milliliter solution. That is a lot. That is, I feel like, again, unrealistic. And yeah, of course, this problem is awfully written and is unrealistic, but it's how you do it, and it's a mathematical approach. From here, I could figure out how many grams of cadmium, but that would be a tremendous amount of grams of cadmium. I wonder if that many grams of cadmium even exist on the planet. Probably so. But anyways, that is our solution for this. So this video is going to be long, but it is going to go through a ton of different practice problems. I definitely recommend going through these yourself.
Students, you have until 4 p.m. today to make selections for Raider Time tomorrow. If you do not make a selection, you will be automatically assigned to a teacher, and you must report to that teacher.
Sorry, I'm not going to edit the announcements out. I don't know how to use iMovie that well. But what I definitely recommend is going back and looking through question types, making a question of the same type and working through it alongside me, as opposed to just looking at this as a key. To be sure that by the time you're looking at assessment style questions, you've seen questions like these 3, 4, or 5 times and you're really prepared. So thanks for watching and good luck.